Hello everybody. I'd like to share about this project I'm working on for the last few days as a quick learning project in Python. I learned a lot from this project, and even though it's extremely simple, this is an overview of the results of making Pong in Python. The code is still a bit messy and unPythonic, so if anyone has any suggestions I could implement or spot any bugs, please put it down in the comments. So this project has three modules, as you can see on top: pong.py, pong.plots.py, and pong.test.py. Let's start with the first file, pong.py, which defines game elements in the engine. First thing I do is define window size, which determines the placement of game elements on the board, and then we create classes for each game element. So we start with the paddle, which we initialize with the size and its side, which controls where it starts on the on the on the screen, which is the exact middle of the side. I then create a sprite out of a Pygame rec based on the starting position. Next, I create a method that draws the sprite on a screen. Next, I define the move method, which simply moves the Y value of the paddle and sprite down or up depending on input. It's redundant that I'm updating both self.y and self.sprite.y, which are supposed to be equal at all times. When I realized that, a lot of other functions were already built on paddle.y and paddle.sprite.y, so I kept it in. Next, I deal with the paddle ball collisions. But next, we have this monster function that does paddle ball collision. The function both manipulates the ball itself and returns true or false based on whether the ball bounces. So if the ball's already moving the opposite direction away from the paddle, if it immediately tags it as false to prevent double bounces and self goals when it bounces on the side. Secondly, I take the the rectangle hitbox of the ball and collide it with the sprite, and then we normalize the spot where the ball lands on the paddle as between -1 and 1, scale it up, and then apply the as a new y val so as to make it go different directions based on where the ball landed on the paddle. Then it reverses the x velocity and then move it in front of the paddle to prevent double hits, and then applies the velocities that we calculated to the ball. Next, we have the ball class, which is quite simple. We initialize it at the center of the screen, and we start with an x velocity of 0 in pixels per frame, and then we create a rect for it. And then every single time we have a function to apply val, which changes the velocities of the ball, and then every single loop, this function here called step is a, a run which changes its x and y value based on the velocities and updates its rectangle. And then we have a function that simply draws the circle on the screen. Next, we have the object that's most important that ties all of our game elements together. So we have a function that initializes all of our game elements, gives a random serve direction, initializes no winner and the score is at 0, and puts bots in the system. Next, we have the control function, which determines what paddles move. So if there's no bots in here, which is the default, we take the keys from Pygame and move the paddle based on the keys. And then we have a draw all function, which draws the score on the screen with text, and then draws all of our elements onto the screen. We also have a function some logic here. So if the ball is still and then we're not waiting for anything, we will simply put this is when the ball is in the middle after the goal is scored. We have to serve it, and then we reverse the serve. We multiply the serve direction to change the direction where the ball goes after the wait. And then if we're not in a wait period, we we do the collision in logic and step the ball, and then we draw the ball on the screen. Point of waiting is to give some time between rounds. So next, we have the main loop of the function which contains a loop that runs while the main game is running. So first, this don't start part is just in case if we exit from the beginning of the game before we start the game, we'll immediately exit the game. And secondly, we start a window, a 3 second window before the first serve happens, and then start the loop. First of all, if we quit the game, we simply quit the loop. We fill the screen with 0, and then we do controls, call the draw function we just called, and then change and then exit the game if we ever reach 25 points and declare winner. And then we flip the frames and to run on a 60 frames per second game. Next, we have a starting loop function, which puts a title page, which runs the Python Pong text and a button, which keeps tracks of your mouse pointer and stops this loop when you click the square button in the middle, which is just a rect. Next, we have the wall collision code, which first it takes its own ball X and ball Y, and then if it hits if it's on the bottom, if it hits the top or bottom of the screen, it simply reverses the y velocity and bounces from the top of the screen. And then if it hits either side of the screen, it resets the ball at the center, freezes it in tracks, and raises the score, adds the weight, and then changes the serve direction and returns true. And lastly, the ending screen, once the 25 seconds is over, if there's no winner at all, which is when we exit this the main loop early without declaring a winner, we simply return itself, and then we create a new font and render with a screen and we'll change the color depending on who won, lit it to the screen, flip it, and then and just just wait for the game to end at a 40 FPS check. And then lastly, we run all our functions, we create our screen, initiate Pygame, declare all of our objects, start running, and then put it into a game object and run the 3 starting loop, main loop, ending screen functions that run our game, and then quit Pygame. So let's take a trial one more time, run this file. You see you have a screen, and then we have both connections can decide based on keybinds, and it bounces properly and changes direction based on where it lands, and it speeds up slowly. That. So in Pong Bot.py, the first thing we create is an abstract-based class called bot, which is kind of an interface that works with the game object from Pong, and then it must use a function called getAction, which gives an action, and it takes in a paddle and a ball and declares it to itself. Secondly, we have the first usage of the bot is a simple bot, which is a simple adjustable difficulty bot that mostly tracks the ball. So it takes in the paddle of the ball and skill level and target noise uh parameters, which affects the ball's performance. First, initialize it and take in all the parameters as class fields, and then the get action function is done by giving the center of the paddle and the ball's y, and then offsetting it by a random Bayesian target noise and has a less than 1 minus skill level chance of doing something completely random. And then we use a ball y and offset to target, and then we basically use the target and we have let's use the target and paddle center to target the paddle itself to the to the ball, and then because based on that, we move up and down. So the point of pongbot.py is to create a reinforcement learning bot to play the Pong that I built. So we need to make an environment, a gymnasium environment to wrap our game object. So first, we have an action space of 3, which is 0, 1, 2, which is will be later mapped to -1, 0, 1. And then we have our game element and a bot as an opponent. And then we have an observation space of 6 values in a box. We keep track of enemy score and our score. Secondly, we have our step function, which is run every round. We run we run controls and we reuse a bunch of our normal step functions from Pong. And then if it bounces, we gain zero point 0.3 reward. And then if we get closer to the ball at a certain distance, we gain a reward. And then if we're getting closer to the ball and we're moving when the ball is far away, we get reward. If we don't, we're losing, we lose reward. And then if we score on them, we gain 5 points, and if we win, we get 200 points, and we stop the episode. If the opposite is true, we lose 2 points and lose 200 points and stop the episode. And then this is the serving logic, and then we take our paddle x and y, the ball's paddle x and y, and their velocities, and then return all them back, the environment and the agent. The other function that we need to make an environment is reset function, which resets the seed, and then we reset all the scores and make new instances of the game and the new bot, and then we give the initial observation. So once this is done, we start this program by doing an if name equals main, because if we ever want to import this function, this won't run. So we initiate Pygame, we create our elements again, and set our model path to DQNbot. So if the already from immediately existingly trained model, we can load it in. But if there isn't any model, we can create a new one, and then we can learn for 3.7 million timestamps, which is about uh 500, 500, 600 episodes depending on the bots, and it takes about an hour and a half depending on your hardware. So this model called DQN, which creates a Q table, which is a prediction of the rewards it will get next tick. And then using the policy that creates, it uses to make that table. And then it will run whatever the table says it will give you the most reward. And then the tick plays out, and then if the rewards were different than prediction, they will update the table and revise the policy to make a more accurate prediction until the bot follows the rewards. And then lastly, we will run one last test episode and print the final reward and then save the bot policy. I trained it for a total of 6 million steps in total and then so it took about 2.5 hours. And lastly, let's look at the last file, Pongbot's test. The Pongbot's test is a really short uh file. First, we create another bot, which uses the same interface as the old bot, the simple bot. And then all it does is takes a directory and load the current DQN bot saved here. And then we use like the get action is implemented by taking the observation from from the game and its current from the paddle it got inputted in and then sends it to the prediction and then returns the action -1. So how we test it, we run the same thing from Pong, which is we initialize Pygame, create a screen, initialize our game elements in our bot, create a game, and we run the starting loop, main loop, and ending screen. So let's run it, and as you can see, the entire right side is completely autonomous and not controlled by me, like last time it was. Wait for it to run. Take some time. Oh, here, now it runs, so it can run. See it's moving by itself. You can see it goes by itself, and it will return the ball. Okay, let's stop it for now. So, as you see, the ball is not perfect. The robot tends to overshoot often, so if the missing the ball, so if the ball is an insanely far shot and goes really fast, it usually overshoots. So my training rates aren't perfect, so we can make changes that penalizes more for outcomes that do too much. And we can change similar problems by changing the weights. Overall, it was a great experience learning Pygame and Gymnasium, as well as looking to reinforcement learning and creating a game. So, anyone has any suggestions on changing training weights or solving some problems, or want to try working this for more, please put it in the comments, and I'll see you next time.